Good day everyone. In the other video, I talked about logarithmic differentiation. In this video, I'll also talk about logarithmic differentiation, but how to use logarithmic to differentiate functions of this form. Y equals to square root of x plus 1 close bracket raised to the powers of 3 all over open bracket x minus 1 close bracket open bracket 2x plus 1 close bracket raised to the power 2. It's simple as ABC. Just help me share this video. Make sure you like it. Thank you and God bless you. Okay, let's look at it together. Amen. It's simple as ABC. Don't assume that mathematics is difficult. Mathematics is not difficult. Sometimes it's all about the individual who is teaching you. It's okay. But here I'm going to break it down for you. Amen. It's okay. Let's write solution. Solution. Our y is equals to x plus 1 all raised to the powers of 3 close bracket then square root all over x minus 1 and 2x plus 1 raised to power 2. Amen. Okay. Now, in the other video, the first video, I looked at laws. There are 3 laws governing logarithmic differentiation. Let me remind us here again. Okay. One of the law says that if we have in A times B, this is the same thing as in A plus in B, two of us. So we assume that we have 2 functions are multiplying each other. This is a function A, function B. So we can simplify it this way. That's the meaning of this. Then 2. If we have in A all over B, that is 2 functions are dividing each other. Amen. So this is the same thing as in A minus in B. So you express it this way so that it will be easier for you to differentiate any given function. Take note. Thank you. Okay. Then 3. If we have in A raised to the powers of n, this n could be valued either raised to the power 3, 2, or half, 1 all over 2, and 1 all over 3. This implies that you can express it this way, n in A. So this will help you to differentiate the function very well. So you must put this at the back of your mind before you know how to use logarithmic to differentiate any given function. So now here, you will see that I will apply all of these 3 laws. Amen. Okay, so let us look at it together. I will take it step by step so that you will know it and understand it better. Amen. Okay, because I want you to know it more than the person that is teaching you now. And that will be my joy. Okay, so now let's look at this idiot. So if you can see what I am saying, okay, I want to do one funny thing here. Look at that. I just want to consider the numerator. This square root of open bracket x plus 1 close bracket raised to power 3. Note that, go back to indices. Note that if we have a raised to square root of a raised to power 3, then this is the same thing as a raised to power 3 close open bracket raised to the powers of 2, 3 of us. So here we are going to apply power law. This is power, this is another power. So 3 times half is going to give us a raised to the powers of 3 all over 2, 3 of us. Do you agree with me? Okay. So if you agree with me, let's consider this idiot this way, this numerator. Okay. So, okay, for the fact that we are using, let's make use of this one so that you understand it better. So note that if we have square root of x plus 1 raised to the power of 3, this is the same thing as x plus 1 raised to the power 3, open another bracket, raised to the power 1 all over 2, because this square root is 1 all over 2. Amen. Then this is equals to, amen, this is equals to, we apply power law here, x plus 1, open bracket, 3 times half. Then this will going to give you x plus 1, 3 times half is 3 all over 2. Is that clear? So now, instead of this, we'll simplify it this way. So here, the numerator will now, our y is equals to x plus 1 raised to the powers of 3 all over 2 all over x minus 1, open bracket, 2x plus 1, all in bracket, raised to the powers of 2. Don't mind my daughter, she wants to also teach mathematics. It's okay. Yes. Okay. So let's look at it this way. What we will do here is we are going to take logarithmic on both sides. Amen. We will take log on both sides. Let us take logarithmic on both sides. If we take logarithmic on both sides, this implies that in y is equals to, in open bracket, x plus 1 raised to the powers of 3 all over 2 all over x minus 1 all in bracket, 2x plus 1 raised to the powers of 2. Amen. Okay. So you agree with me? So if we differentiate in y, we are going to have 1 all over y dy all over dx, because we are differentiating with respect to x, of course. So that is that. So if you agree with me, this implies that let us have it in this way. This is the same thing as in, amen, x plus 1 raised to the power of 3 all over 2 all over in, amen, x minus 1, open bracket, 2x plus 1 raised to the powers of what? 2. Amen. Okay. You will see that I will be making use of these 3 laws. Okay. Now, we now recall. Amen. Can I take off this part? Let's recall. I hope you are following me. Okay? So let us recall. Let's recall. Let us recall that if we have a head, look at this numerator. Amen. The numerator, if we have in a raised to the power what? N. This is the same as n in what? A, isn't it? So assume that this is your A and this is your N. So that is what we want to do now. So our 1 all over y dy all over dx is equals to 3 all over 2 in, amen, x plus 1 all over in x minus 1 times 2x plus 1 close bracket raised to power 2. True or false? Okay? So, if you agree with me, okay? So now, we are going to apply this law. What do we have here? Division sign, isn't it? So look at it. Function A divided function B. Function A all over B. That we can simplify it this way. So let's do it this way. Now our 1 all over y dy all over dx is going to give us 3 all over 2 in x plus 1. True or false? Then, because of this, we are going to put minus, make sure you put the bracket in, all in bracket, x minus 1, and open another bracket, 2x plus 1 raised to the powers of 2, you close the bracket. Amen? Okay. So, if you can see what I am saying, look at this. We have in x minus 1 times 2x plus 1, open bracket, raised to the powers of 2, two of us. So, now we are going to use the first law here. It means we are going to simplify this way, two of us. Okay? Make sure this negative sign, don't rush to open the bracket. Is that clear? So now let's do it this way. Here will now be, okay? Here will now be 1 all over y dy all over dx is equals to 3 all over 2 in x plus 1 minus, open bracket, we want to simplify it this way, since here is multiplication, in x minus 1, then plus in 2x plus 1 raised to the powers of 2, all in what? Brackets. Is that clear? Then, look at one of the functions here. We discovered that we need to apply the third law here, three of us. Look at it. In a raised to the power n, look at it here. In open bracket 2x plus 1, close bracket raised to the power what? 2. So, here we're going to give us, okay, 1 all over y dy all over dx is equals to 3 all over 2 in x plus 1 minus in x minus 1, then plus we apply this law here, 2 in 2x plus 1, close the bracket. This is plus 1, close the bracket. Okay. So, you can see that we are solving this mathematics step by step and breaking it down for you to understand and know it better than the person that is teaching you, two of us. You discover that this minus, I refuse to open this bracket, two of us. Okay, so now let us open this bracket using this, note that there is an invisible one, sorry. So here will now be 1 all over y dy all over dx is equals to 3 all over 2 in all in bracket x plus 1. Use this, note that there is an invisible one here. To multiply, we are going to have minus in x plus, sorry, here is minus in, yes. Then use this minus to multiply plus, it will be minus 2 in 2x plus 1. Is that clear? So now, we can now differentiate this. Is that clear? We can now differentiate this. Okay. Before I differentiate everything, all the functions here, there is something I want you to take note. Amen? Like here, okay, where will I do it? Okay, let me just do it here. Assuming you are asked to differentiate y equals to in, amen, in 2x plus 1. You know, if you are to differentiate just y equals to in x plus 1, note that your dy all over dx will always give you what? 1 all over x plus what? 1. Take notes. Yes. But here, look at this function. We have in 2x plus y. It means for the fact that the coefficient, x has coefficients here, which is 2. It means you are going to use what is called chain rules to substitution. Is that clear? But if you don't want to use the chain rule, we can differentiate it directly to give us what? Our dy all over dx is going to give us what? Instead of 1 all over, it will give us 2.1 all over 2x plus 1, which is the same as y all over dx is equals to 2 all over 2x plus 1. This is what you are supposed to get if you are to differentiate functions of this form. Is that clear? So please take note. Are you following? Take note. So whenever, even if it is 3x plus 1, is same thing, it means it will be 3.1 all over 3x plus 1. So please take note. Amen? Okay. So now let's do it together. Do you agree with me? Any question? Okay, no question. Okay, so let's solve it together. If you agree with me, so 1 all over y dy all over dx is equals to 3 all over 2. If we differentiate in x plus 1, it will give us 1 all over times 1 all over x plus 1 minus differentiate in x minus 1, it will give us 1 all over x minus 1, then minus 2 times differentiate in 2x plus 1. It's going to give us what? As I told you, it will going to give us 2 all over, okay, for the sake of math and dot, this is times, or let's put bracket here. It means 2.1 all over 2x plus 1, close the bracket. Amen? So our 1 all over y dy all over dx is equals to 3 all over 2.1 all over x plus 1 minus 1 all over x minus 1. Then use this minus 2 to multiply 2 times 1 here. Going to give you minus 4 all over 2x plus 1. True or false? Okay. You see that these laws are very important. All through the differentiation, we have been making use of this law. So that's why I said earlier that one need to know this law offhand. Is that clear? Because it's this law, most especially in logarithmic differentiation, it's this law that you will use. Amen? So now, can I claim this part? Okay? Let me claim this part. Okay? So now, what we need to do here, there is something we need to do here. Amen? We have to cross multiply, use this y to multiply this. If we use the y to multiply this, now the left hand side will be left with 1 times dy all over dx. It's the same thing as dy all over dx is equals to y times, amen, this is y, times open bracket, this function. That is 3 times 1 is 3. Then here will now be 3 all over 2 times x, it will give us 2x plus 2 times 1 will going to give us what? 2, isn't it? Minus 1 all over, let me also clean this part. Okay, 1 all over x minus 1, then minus 4 all over 2x plus what? 1. Amen? But note that your y here is given as this idiot, true or false? Y is this. So instead of y, you write this function here. So therefore, your final answer will now be dy all over dx is equals to, okay, amen, is equals to square root of x plus 1 close bracket raised to power 3 all over x minus 1, amen, open bracket 2x plus 1 raised to the power of 2. Then we write out this one, open bracket 3 all over 2x plus 2 minus 1 all over x minus 1 minus 4 all over 2x plus 1. This is your final answer. Any question? No question? Thank you and God bless you.